Every developer wants fast access. Every organization wants strong security. And GitHub administrators have to make both happen at the same time. GitHub administration is basically one job. Help people move fast without giving away the keys to the kingdom. I'm Michael Michel, and in this session, we're going to build a simple framework you can reuse anywhere. Where administration happens, team, organization, and enterprise. How users prove who they are, that's authentication. And how you control what they can do, permissions. By the end, you should be able to explain GitHub admin structure and permission levels, identify authentication options you can use to secure access, and describe how directory-based approaches help you manage users and teams at scale. Think of GitHub administration as layered control, from small teams managing repos up to enterprise-wide governance across multiple organizations. GitHub administrators operate at 3 levels. Team level, managing groups, permissions, and collaboration. Organization level, managing users, repositories, and security. And enterprise level, managing policies, identity, and governance across organizations. At teams, what you need to do is to manage permissions, and you need to manage it at scale. So instead of assigning permissions to individual users, you can group them and assign them access. Teams mirror your organizational structure and improve collaboration through team mentions. You can nest teams. They can inherit permissions. So with larger organization, it's easier to group users with similar security requirements with similar permission needs and assign them permission once, as opposed to giving them individual permissions to different places. In addition to this being a reduction to the amount of administration overhead, it also keeps consistency with larger organizations. So instead of managing individual users on multiple organizations, we will be able to manage those users together and give them access to multiple repos within those organizations. There's also the ability to sync the team with your intra-ID synchronization, for example, or any other identity provider. So I will be able to mirror my organization structure. I will be able to mirror my organizational order of how users are managed within teams and map that to what we have on GitHub. Teams in GitHub group those users, so you'll be able to manage them at scale. That's the main concept. So you can assign permission once to the team, and then every member in that team will be able to inherit it. So this creates more structured environment. You can also assign permissions based on roles, projects, or departments. It gives you the ability to improve communication because now user can mention teams in discussions and they will be alerted, notified. And with nested teams, permission can cascade from parent to child. Teams simplify access, simplifies control, and makes collaboration more efficient, consistent, and easier for you to manage and view. At the team level, there are 2 main roles. You can either be a team maintainer or you can be a team member. A team maintainer is a team manager. Their main idea is they will be able to add, remove members, they will be update settings, they will be able to add sub-teams, and they will be able to look at the entire hierarchy of that team, especially if it's nested in multiple teams. And then we have a team member. A team member focuses on collaboration. They inherit any permissions that are assigned to the team. For example, repository permissions. They will be able to participate in discussions, but they don't manage the team itself. So permissions are separated from management responsibilities. That means everybody in that team, if they have a write permission or if they have a certain permission to a place or a repository, everybody in that team will have that permission. But when it comes to managing, that's the role. This is mainly for maintaining the structure and control. So organization owners can promote members to maintainers when that is needed. As you're assigning permissions, as you're assigning roles, it's important to audit access. You can audit access to repositories. You can view a centralized list of all the users, all the teams, and collaborators from the repository settings. This gives you a clear picture of who has access and what level of permissions they have, whether it's direct user access, team-based access, or external collaborators. As an administrator, it's important that you regularly review the list and ensure access is still appropriate. Remove unnecessary permission and maintain security and compliance. It's important to always know who has access, always validate that this access is what the business needs. At the team level, there are a few best practices that help you scale effectively. First, use nested teams. Add teams inside teams. This will mirror your organizational structure. This will simplify permission management as the teams grow. And then create teams based on skills or technology. This will streamline some pull request reviews and also assign right reviewers quickly. Finally, if possible, enable synchronization with an IDP, identity provider, such as Microsoft Entra. This automates onboarding and permissions and access removal, simplifying some of those tasks. Instead of manually having to adjust them and change them, you will be able to simply synchronize with whatever directory structure you have. So structure teams intentionally and use automation to reduce any manual effort and improve consistency throughout your organization. GitHub organization is your central workspace where multiple teams can collaborate and access projects. Administrators are able to manage users, manage repositories, permissions, and security all in one place. The best practice is to use a single organization whenever possible. If you create multiple organizations, you lose some shared configuration. Means everything might be set up from scratch each time. So every time you create a new organization, you have to set up some of those settings, additional administrative overhead. This can also introduce extra cost and increase complexity. So keep it simple, use one organization to scale security and efficiency whenever possible. At organization level, administration focuses on managing access and governance across all projects. We're looking at multiple different repositories under a single organization. Now, I can invite or remove users to my organization. Then they will have access to the repositories inside that organization. I can add users to teams inside my organization and give them access to repositories under it. I can also invite outside collaborators and give them roles that is part of the repository. So they will be able to do things in my repository without being part of my organization. You can also include some repository permission access and settings and default permission on your organization level. You also will be able to handle security, billing, and automation, helping maintain consistency across the entire environment. And by environment here, we're looking at multiple organization or multiple repos under one organization. So the organizational level administration is about central control, ensuring people have the right access across the repositories. At the enterprise level, now we're talking much bigger. Now GitHub allows you to manage multiple organizations under a single umbrella. Now I can have multiple organizations under one enterprise, and those organizations can have multiple repositories. So we're talking about repositories under organizations under our enterprise. So we're talking on a much larger scale. Enterprise account, they run on GitHub Cloud or GitHub Cloud's Enterprise Cloud or Enterprise Server, depending on the environment. Are you going to host it on the cloud or are you going to host it locally in your environment? The main value here is centralization. You can enforce policies, manage bills, and apply security controls consistency across all the organizations that you have. From user perspective, enterprise allow them to manage access centrally. So they can integrate with their own identity provider. So they can connect, for example, their Entra ID and have a single sign-on, whether they're going to be writing codes or they're going to access other enterprise-wide resources. This ensures that users have right access across organization and maintain security and governance. So enterprise administrators focus on scaling control and consistency across the entire GitHub environment. Administration at the enterprise level includes multiple different layers, multiple different products that you're going to manage. So at enterprise level, you have central control access across all the organization. So you might enable SAML, SSO, single sign-on. You can connect the enterprise identity to GitHub for secure access. Now the users will be able to sign in, and all their sign-in requests is going to be redirected through their identity provider. Enterprise owners also manage the organizations themselves. So maybe adding, removing, or handling any billing centrally for all the different organizations. Also enforcing policies and security settings. It's one of the major responsibilities, one of the reasons that sometimes enterprise administrator focus on more than anything else. Because when we had multiple different organizations, multiple different repos, we want to set up something. If I don't have an enterprise policy, I have to go to each one of those organizations and set it separately. Automation is also important. I can automate through scripts, maybe analyze data, or perform any large-scale change. Using some of those automated skills, some API calls, I'll be able to either push change or pull change from my entire organization using fewer steps, and it will take less time. So enterprise owners ensure security, consistency, and control across the entire GitHub environment. Now let's look at how users authenticate with GitHub. This really answers the question of, who are you? The most basic option is usernames and password, also known as basic. This basic authentication is not recommended, especially in the enterprise environment. It is less secure. Instead, GitHub promotes using PAT, which is Personal Access Token. It's essentially a secure token that replaces your password when working. You can use it in the command line. You can use it when you're logging into the web interface. But with scripting or calling a GitHub API, you can always pass that. So instead of typing password when pushing the code from your local machine, you use the token. The token can be scoped. For example, I can give access token to a specific repository or perform read operation on those tokens. Makes it much more secure and controllable. So avoid passwords. Use token with scope permission. That is the security best practice advice that I have for you. There are other options, including SSH keys, which are one of the most common authentication methods for developers. Most developers that use code or they're connecting from different CLIs, they will be using SSH keys because you can authenticate using our secure or your secure key pair. So a public key that's stored in GitHub and a private key that's stored on your local machine. Once configured, you can interact with GitHub, just like cloning, pushing code, or even re-entering credentials, without re-entering credentials. So for example, a developer is working daily on their laptop. They can use the key to push code without typing the password every time. It just looks at that private key that they have locally and use it for authentication. We have deployed keys. They're a bit different. They're designed for automation scenario, and they're not tied to a single repository, not to a user. For example, if I have a CI/CD pipeline pulling code from a repo, a deployment server accessing a repo, by default, the deploy keys are read-only, which is safer, but you can enable write access if needed. So use SSH keys for developer access and use deploy keys for automation and systems. So when using SSH or deploy keys, security best practices are critical. It is important that you use strong phrases to protect private keys, adding an extra layer of security. Also, follow a rotation strategy so that you regularly replace keys and reduce the risk of long-term exposure. Also, apply the principle of least privilege. Only grant the permission needed, typically read-only for deploy keys. Finally, monitor and clean up keys regularly. Remove any that are no longer in use. So treat keys like credentials. Secure, limit, rotate, and monitor them. Monitor them regularly. Beyond authentication methods, GitHub also includes additional security layers that you can use to enforce the security, such as two-factor authentication, or 2FA. It adds a second step when the user logged in. So first, can prompt them for password, and then the code on a computer or an authentication app, where the users just have to open the app and choose it or type the code that is there for them. This means even if a password is compromised, an attacker still can access the account without the second factor. So from an administrative perspective, One of the most important controls is the ability to require 2FA across the organization. So if a developer does not enable 2FA, they can be blocked or removed from the organization. This will ensure that every account accessing your repositories meet the minimum security standard. In real-world scenario, this is often a baseline security requirement for enterprise environment. So authentication really protects the identity, and the two-factor authentication, or 2FA, protects access, even if identity is compromised. Also, we can move to the enterprise-level authentication. With enterprise-level authentication, we can enable SAML SSO. SAML SSO stands for Single Sign-On, using an identity provider, like Microsoft Entra ID or Okta. So instead of managing user IDs directly on GitHub, you rely on a centralized identity system. Here's how it works. When a user tries to access GitHub, they're redirected to the organization identity provider to sign in. Once authenticated, they're redirected back to GitHub with access granted. So GitHub is essentially trusting an external identity provider. In an enterprise environment, when an employee logs into GitHub, they use the same credentials as their corporate account. No separate GitHub login is needed. This has two big advantages. First of all, centralized controls, because access is managed from one place. Security and compliance, easier to enforce policies like MFA and conditional access as well, using single sign-on. So single sign-on connects your GitHub to your enterprise identity system. This will simplify access and improve security and governance in your organization. Another enterprise authentication option is LDAP, which stands for Lightweight Directory Access Protocol. LDAP allows GitHub Enterprise Server to connect directly to your organization internal directory service, such as Active Directory. So instead of managing users separately in GitHub, authentication happens against your existing corporate directory. So for example, a company already using Active Directory for internal system can use LDAP, so employees log into GitHub with the same credentials. When a user is removed from the directory, GitHub access is also being removed. This makes identity management more consistent across systems. Compared to SAML SSO, LDAP is more common in on-premise environment, while SAML SSO is more common in cloud-based identity systems, like Entra ID. So, if you have Entra ID, you're going to use SAML SSO. If you have on-premises environment, you're most probably going to be using LDAP. So LDAP connects GitHub to internal directory service. It centralizes authentication in the enterprise environment. The same concept is we're trying to simplify the way that we create users sign in. Now we'll shift gears and talk about managing access and permissions at scale. We focused on authentication earlier, how users prove who they are. Now we're going to focus on what they are actually allowed to do. So after I sign in to my GitHub account, whether I am going to be using an LDAP or SSO or any type of other access, what else am I going to do? As organization grows, managing access becomes more complex. You're no longer dealing with just a few teams that you're managing. Sometimes you have multiple repositories, multiple teams, even multiple organizations. So in this section, we'll look at how we can structure permissions across all of these layers. Let's talk about how permissions works on organization levels, how they extend to the enterprise level, the difference between internal users and external collaborators, and the most important is how to apply the least privilege. For example, a developer might need write access to only one repo. Maybe a security team might need read access across all repos. A contractor needs temporary access to just one single project. The goal here is to give people just enough access to do their jobs, no more. That balances access and control. That's what's create governance. And this is really what it's all about. Let's talk about repository permission level, which is the lowest level that we have. Defines what user can actually do inside a repo. These are 5 levels. Each one builds on the previous. So starting with the lowest level, which is read, allows user to view the code and comment on issues or pull requests. We have the triage role, which is for project managers. So they can organize issues, but they can't pull or push code. And then we have write. That is the developer permission. So most developers use it. They contribute and they push changes. Then we have maintain. Maintain allows managing repository, allows managing all of the settings without full administration control. What does that mean? That means admin, or the permission of admin, provides you that full control. Can manage permissions, they can even delete the entire repo. So for example, if we have a contractor that's reviewing code, they might get read. If I have quality assurance or project manager, they might get triage. Developers get write, and a tech lead might get maintain. And only a few people should have the admin. The key concept is least privilege. So always give users the minimum access they need to do their jobs. This reduces the risk while still enabling collaboration. So you're securing the environment without affecting productivity. Users can receive repository access multiple different ways. Not just in one single assignment. It's not that I only assign users. No, there's three main ways. We can do direct repository roles. We can be part of team membership. And we also have organization level permission. Because access is layered, the user might inherit permission from several places at once. So multiple access, all of these access will apply to the user if the user is a member of certain organization, a member of the certain team, and has a certain access to the repo. So we apply the highest level of access a user has across all resources. So for example, if someone has read through a team, but write directly, then they have write access, because you need write to read. You need read to write. Always consider all permission sources. GitHub uses, again, the highest level controls. Think about it from the other word, it's combined. So if I have read and I have write and I have maintain, then my last permission is going to be read, write, and maintain. We add them, whether I'm taking them from team membership, organization membership, or direct assignment. There are several ways users can receive access to a repository. It is important to understand each one. Users can be added directly as collaborators with specific roles. This is common, external contributor or small teams. Second, access can come from team membership, which is preferred approach, especially when we're trying to scale access. So permissions are managed centrally through the membership to those teams. It can also be done with what we call default permission. That applies to all members with the ability to override them when needed. So for example, I can set a default permission to a certain repo as read. So everybody that is part of my organization will be able to read that. But then I can remove access or give specific people additional. For example, I can give developers write. Outside collaborators also is a non-member, like contractor. They will be able to access specific repositories, but they will not join the organization. So choose the right access method based on the scale, security, and collaboration needs. Monitoring and auditing repository access is critical for maintaining security and compliance. So start by reviewing access directly in the repository settings. That's where you can see who has access and what is the level of access that they have. At a broader level, I can, on an organization and enterprise audit logs, I'll be able to track changes to permissions and membership over time. For larger organization, I can enable automation using APIs, where I can continuously monitor access and detect anomalies. Finally, adding controls like branch protection and required reviewers help enforce accountability for all changes. So regularly audit and monitor. Ensure that the right people have the right access and nothing more. Now we'll move into managing access and permissions at broader scale. So far, we focused on individual repository and authentication. Now we're stepping back and looking at the bigger picture, how everything fits together across the organization and beyond. At this level, you're not just assigning permission to one repo. We're thinking about who should have access across multiple projects, how teams are structured, and how to enforce consistent security policies. So we'll walk through a few of those areas. We'll look at organizational permissions, what can be defined, which user have what access to the repository. Then we'll look at enterprise permission, Multiple organization, now we're looking at different approaches. How can we assign on all of those different repositories or all of different organization and the repositories under them? We'll also look at the difference between internal users and external collaborators. We'll dig a little bit deeper here, especially the importance, this is especially important for contractors or maybe partners. And we'll focus on least privilege and governance, making sure users only have access that they actually need. For example, a contractor might only need access to one repo for a short period of time. A security team might need visibility across everything. So the goal here is to keep it controlled and be able to scale it and make sure that it is secure. Remember, we need to still be able to enable teams to move quickly. When we look at an organization permission, repository permissions control access to the repo. Organization role now define what you can do across the organization. So at the top, we have what we call an owner. So they have full control. That includes managing users, security settings, billing, pretty much full access. This role should be very limited, maybe a few trusted individuals. Most users should be members. Those can create repositories. They will be able to collaborate across the organizations. And then you move to a more specialized roles. Maybe you have moderators, people that manage discussions, community interactions. You have billing managers, those handle billing without access to code. And security managers, who focuses on security alerts and policies. And finally, outside collaborators again. These are external users, like contractors. They get access to only specific repositories, not the whole organization. For example, if I have a full-time engineer, that's a member. A security lead, that's a security manager. A contractor, that's an outside collaborator. So organization role, control broad access. They keep high privilege roles to a minimum. Minimum number of users should have access, for example, as an admin or an owner. Organization levels, you can set the default permission. This will apply to all members across the repositories. So best practice is we set default access, for example, read, and then grant higher as needed. This helps improve security and keep access control. However, there's no right approach here. It really depends on the environment. Smaller teams with highly trusted environment might choose broader access. For example, they might choose by default write. This way they can move faster. The key is really balancing that security and productivity. Do not over-restrict, but also avoid giving more access than necessary. So start with that baseline and then adjust access based on the different roles that are needed. Enterprise permission level can also be defined for the overall environment. That means multiple different organizations. So enterprise owners have full control. They manage admins, they enforce policies, they enforce those policies across organization, and they handle billing and settings, again, across organizations. And then we have enterprise members. Those have similar capabilities to organization members. They focus on day-to-day collaboration. We have billing. Those are limited to the financial task, managing billing without access to any of the technical settings or the code. And we have the guest collaborators. You can grant them very specific access to resources as needed. So enterprise roles and responsibilities need to be separated, ensuring that you have secure access and controlled access at scale. We can also set default repository levels. So we can set default repository levels. This is a key governance decision. So instead of assigning access repo by repo, now we define a base level of access. We set that policy of the repository access. That's important to remember. This is a policy that we set for the repository access, and we define the baseline for all the members. We can have no access, we can give them read, write, or full admin. That's very rarely recommended, the full admin. Most enterprise scenarios, the best practice is start with read access and then grant additional permissions only when needed. So if a new developer joins the organization, they automatically get read access. They automatically get read access to the repos. And then you give them the right access based on their project, based on their team. A contractor might only get access to one repo throughout the team that they gain access to. So this reduces the risk and makes access easier to manage at scale. To take this further, organizations use nested teams to reflect structure and inherit permission. Automation and audit logs are used on an enterprise level, so we will be able to monitor access over time. So set a safe default and then layer access on top of this. This keeps your environment secure and scalable. Now let's talk about enterprise-level permissions and policies, which is where governance really comes together. At this level, you're not just managing a single organization. We're managing multiple organizations under one enterprise. The goal is consistency and control. So instead of configuring settings individually, we define policies. And these policies will apply across my entire enterprise or across your entire enterprise. You can enforce security requirements across all organizations, standardize default permissions, or apply consistency rules to your repository. This is where concepts like rule sets and policy enforcements comes into play. We will look at identity integration as well. We will look at automation using APIs or GitHub Action and managing access to reduce manual work. For example, a large enterprise might automatically assign teams based on AD group or run scripts to audit access across multiple organizations. So enterprise policies help you scale securely. And you define rules once, they apply against or across your entire organization. One of the biggest decisions in GitHub Enterprise is whether to use a single organization or multiple organizations. It's not a one-size-fits-all. It really depends on the structure and the requirement. What can we do with a single organization? Well, everything's centralized. Permissions, policies, repos are managed in one place, so it makes it easier to maintain consistency. So small to mid-sized company might use a single organization, so all teams can easily share code and follow the same standard. But there are trade-offs. Less flexibility across teams, and if something is misconfigured, it could impact the entire organization. So on the other hand, multiple organizations allow you that separation. So each team or business unit can have its own policy and control. For example, a large enterprise might separate organization by region, department. Maybe they have finance, engineering, HR. That improves the isolation and adds a little bit of complexity. So it does add complexity when you have more than one. It's also more overhead to manage. And collaboration across organization can be a little bit harder to enable and manage and assign permissions. So use a single organization for simplicity and collaboration, and use multiple organizations when you need isolation, control, or scale. Now that you understand how permission work across teams and organization and enterprise, let's focus on one of the most important decisions you're going to make as an admin, your default permission model, which is really balanced between security and speed. So a default read means users can view repository but can't make changes unless you explicitly assign them permission. This reduces the risk of any unintentional changes. So it improves auditability. It is ideal for larger organizations when you're working on security-sensitive environments or security-sensitive projects. Where default write model allows you to contribute immediately. So as soon as you join the team, you're able to start contributing. So it improves collaboration, reduces those bottlenecks, waiting until you get the right permission. This simplifies onboarding, but increases the risk of accidental changes or misconfiguration. So in practice, most enterprises adopt the default read approach when selectively grant write access based on role, following the principle of least privilege, for example. Given broad read access across shared repositories while limiting write access to specific teams is a responsible way for maintaining them. When it comes to teams, it's important to remember that we can also synchronize teams with Active Directories. That means creating a single source of truth. While we create teams to monitor our internal organization, if we want to significantly improve automation, onboarding, and role changes, reducing the manual effort, we can do that. We can ensure roles and permissions in GitHub are the same as your organizational structure. It's important to plan for role mapping, define how often synchronization should occur, and ensure proper audit logging for compliance. So AD sync It simplifies user management, but requires thoughtful planning to ensure accurate and secure implementation. Now we're copying, or we're mirroring everything that we have on our directory to our GitHub and enabling automation. That's the difference between not having AD-Sync. AD-Sync add that automation. User added here, user added here. User removed here, user is going to be removed on the other place. So as your enterprise grows, managing those permissions across multiple organizations becomes very difficult to scale. So you need to start implementing automation. You need to start thinking about scripting. It becomes ideal for maintainability, consistency, and security. So instead of updating access once, you can just use a script to standardize how permissions are applied across the different environment. So now instead of going for each organization setting the settings, I have a script that I run and is going to take the effect on each one of the organizations that I have. This reduces the manual effort and minimizes the errors. And to do this effectively, there are some key practices or key best practices that are important to keep in mind. First, design the script with modular component. That means you can adapt, you can try different organization, you can change it, minimum changes. Build your reusable functions so that you will be able to handle different permission tasks. Test scripts in a control environment. Again, because you're running a script that enables automation. If you do a mistake, it's just going to replicate across everything you have. So you need to make sure that you're planning it correctly. And implement detail logging. This way we will be able to track changes and we'll be able to support troubleshooting. And finally, use version control. Your scripts are just code. So you'll be able to manage updates, manage changes. You got to revert back if something goes wrong. So ensure your automation remains reliable, auditable, and easy to evolve as your environment grows. Congratulations on making it to the end of the module. Now it's time to put your knowledge to test with short 3-question assessment. This is your opportunity to reinforce what you learned about different options that we talked about. So let's read each question carefully. Select the response that most closely match best practice on GitHub. What permission level is best for project managers who need to triage and organize issues without contributing code? Triage, read, write, maintain. You guessed right, triage. Which permission level allows users to manage repository settings but not delete or transfer the repository? Maintain, write, admin, triage. Maintain. This session introduces GitHub administration and establishes the foundation for managing access at scale by helping you understand how administration works across teams, across organizations, and at enterprise levels. How authentication ensures users securely and proves who they are and what permissions and what control they have access to. While balancing security with developers' productivity, you can design a scalable and controllable access model for your organization. Thank you for joining us for this session. To continue your learning, watch other videos in the course or explore more on Microsoft Learn at aka.ms/learn.